Hello. Welcome everyone to the next lecture of data analytics using Excel. The next five lectures are going to be in complete synchronization. We will be working with only one tool, that is data analysis toolpath. We're not going to write any functions or codes by ourselves, but we'll actually be able to understand how to use the add-ins we already added in our previous lectures, like descriptive statistics. What we really want to emphasize here on, instead of learning all the statistical methods by ourselves, let's learn the concept and let Excel do all the magic for us. In the next five lecture that we are going to have, I'll be using the same case study which will be related to housing prices in a particular region. And let's see how we can work around with all of such data sets and what are the tools that we need to learn. For the same, you will find an Excel file as well as a Word document with this, attached in the description. You can open up the Word document and you will be able to understand the concepts behind each and every function in the same Word doc. There are not multiple Word docs for each lecture. There's only one consolidated Word doc for you to know all the tools together. We will be starting on by actually working with the regression model, and then we'll be working with ANOVA, correlation matrix. We'll also be working with covariance matrix, and we'll be working with Z-test also. As always, I'm really excited because there's a lot of data analysis and insights that we'll be getting from this entire data set. Let's see how we can dive into everything and work around with the same. I will be working with you. I will actually open up a Word doc to show how you can use it in the first place and where we can actually add all the information. So let's just dive into it. So you can see my screen. As I told you, there's information related to latitude, longitude, housing median age, total rooms, total bedrooms, population, households, and median income, and then median house values. What we want to predict is median housing value, and we have ocean proximity. This is a textual value. We'll see how we can work around with all of these headers together. For now, I will just highlight this a little and then give it more space. I'll do Alt WFF, and now I will actually try to go all the way to the bottom and see how many number of rows we have. We have 20,600 rows, so the data set is very huge already. And we can also actually go here and go to home, go to sort and filter, go with filter, and once we go there, we have 5 types here, that is less than 1 h ocean, inland, island, near bay, and near ocean. And for this, we cannot actually do that. We actually have only 4 categorical values for this one. After doing all the analysis, let's start with our regression model. So for the same, I will actually be opening this Word doc which I have attached. So the first thing that you can understand from this one is I have written why are we using this particular test and how to run that test, right? So you will get the purpose. So whenever you are in a corporate setup and you know that, okay, your boss has, or your manager or whoever, it may be your colleague or it may be you who's in the initiative in the first place, what do you want to do? And once you do that, then you will be able to understand, okay, if I want to achieve such objective, I need to actually go around and work with regression model. So I will actually write regression analysis here, and then we can have how to run regression in Excel and what is the interpretation of the entire process, right? So first is, we actually need to prepare the data in terms of dependent and independent variable and separate them in columns. I will explain what dependent and independent variables are here, and then there's an entire option of how you can actually go around and work around with the same. Right. The same methodology is being followed for almost everything. You can see how we can go around with that. And it's the same for our covariance, and then we have the same for ANOVA and whatnot. Right. So let's see. The important part is our purpose as well as our interpretation. So we'll directly dive into it. But before that, I will actually try to explain you what independent variables are. So independent variables are something that are used as a predictor, and dependent variable is something that you are trying to predict. So in our case, median house value is going to be our dependent variable, right? And if we're going to open our workbook, we can see our input y range is going to be a dependent variable. So y is dependent variable. So this column is going to be our y, and I'm actually going to highlight it so I don't have to think again and again. And everything else that I can think of, from all of these columns, those will be my independent variables. This will be my dependent variable. So as discussed here, what we really want to do is regression is used to determine the relationship between one dependent variable and one or more independent variables. So dependent variable is supposed to be one, but independent variables can be many. It actually helps us to quantify how changes in dependent variables influence a dependent variable. So let's take an example of COVID. How did a particular event, as was which is like widespread, impacted any financial market? How can anything like that going to impact maybe on air pollution? How is Diwali going to impact the air pollution in a particular city and whatnot? Right. So right now, what I'm thinking are just events which you can work on, and you can think of as the event of Diwali as an independent variable, and dependent variable can be the pollution, right? So this is how the basic structure of regression analysis is. We want to predict using the data that we already have, so that we can use it in future. That okay, if this is happening, this is probable, and this is what we can do in certain situations. So we already know what our X are and whatever Y are, so prepare data is also done. Now we need to follow this. We actually need to go to options, add in, Excel add in, analysis toolpack, and okay. We have already done it. What we want to do is actually use this. So we'll actually go around, we'll go to our housing, and then we'll go to insert, page layout, formulas, data. Here we have it. Data analysis toolpack. We have a couple of options here. We'll be working with ANOVA, covariance, descriptive statistics is something that we have already worked off. For your analysis, histograms is something that you can also move around, but I am interested in only one thing, and that would be regression. So let me go around and actually click on regression, click on OK. As you can see, there are a couple of options in front of you now. First thing is inputting the Y range. That is what I'm trying to predict. So I'm going to select this, and you can see it's already being taken care of here. So I'm going to select this, and I'll be doing Control Shift down in order to select everything. The same goes with X-axis. Let's see what's going to happen if I'm going to work with only one first. So I've selected one particular value. Now I have labels, that is my row 1, which is $H $1 is actually a header. That's why I have to write, okay, I want the labels to be there. I want the output to be in the same Excel file. So all I have to do is actually go, okay, I have to minimize this like this, and going all the way to the top, I want the list to be given to me here. And now I want, let's say, I do not want any residuals with me right now, so I will actually go around with just this. And if I'm going to click on OK, let's see what's going to happen. So I have this entire setup made in front of me, and now you can see what exactly is happening. What we want to focus on are some of the variations like R square. Let's see what are those. So the first one is R square, then we have coefficients, and then we have p-values. If a p-value is less than 0.05, the corresponding independent variable significantly impacts the dependent variable. So what do I mean by this is, just like in mathematics, we have a linear equation as y equal to mx plus c. Now m here is a coefficient of x, and c is an error term, or it may be it may be interpreted as a constant term in our regression line. If we are just trying to predict what can be that probable line, and if and only if we have our p value less than 0.05, then and then only we will be working with our coefficient. Otherwise we'll say that okay, this coefficient is not valid for us at all, and we'll not be working with it at all, right? So major thing that we need to work on with is coefficient, that is this one first, and then we have p value. These two will be taken together to understand what exactly is happening. And then we have the R square value. Now R square, the more it is, the better it will be for us. As you can see here, a higher higher R square fit actually is going to predict that okay, this is going to impact very well. What we can interpret from this is 47.34% of the data. If I'm going to control change this into a percentage sign, 47.34% of the data fits well together. Otherwise, that's not the case. What we really want is almost every single time when we have something, let's have minimum of 60% of R square. Right? That's the standard rule for us. And so, 47.34 is nothing for us. We will not be using that at all. Although, let's still try to understand p value and coefficient value here, and then we can work around with more. So, coefficient is 45084. So, our house value is equal to 45085.5767 multiplied by the value of our median income. Once we have that, we can also see that okay, p value is actually pretty well, that is it's less than 0.05 because e to the power minus 248, and then the same go. So it was for the intercept. This is not the coefficient. Coefficient is going to be 41793. So our equation will look like this. I'll actually write it for you. 41. I will not use the decimal signs here. 41793. I'll just write it like this, and I'll write median income, and then plus 4508.5.57. Both of them are actually less than 0.05. That's why we can say we are going to accept it, and it's going to be really good for our entire model. And this is the way we are actually going to move along and write an equation. Now, what we really want to do is take all the x variables together and see if we can make a entire conclusion around the same. So let's try to do it for once. You can do the same for multiple models or all over again, but I will prefer that you work around with this only for now. There are other tools also. We have ANOVA tool also. We have lower to 95 percentile and upper 95 percentile and whatnot. You can work around with the same, but for this lecture we are just going to focus on 3 metrics so that we can create our entire analysis. So I'm just going to go to data again, go to data analysis, and then going to click on regression. And instead of writing H here, that is the input range, let's start with A here, and let's see what's going to happen. So I'm going to start with A. The second thing that I want is this to be A as well. And okay, I do not want this to be like that. And oh, sorry, I need this to be H actually, because that's when I will actually have all the columns selected from A to H. So okay, it looks good. I have everything selected, and I want my output to be in L2. If I'm going to click on OK, there is an error here which is telling me that we have multiple pointers here, which is here. It's very small to see actually. That's why I'm not able to do it properly, but never mind. Click on OK. Functions returns error. Please check input ranges again. So instead of that, I will just select everything from the very beginning. I will not actually go around with this instead. Yep. So I'm going to go here and then all the way to the top using this bar, and Y will be this size, and then X. Let's take 2 variables first for our X so that we can know how we can work around with more as well. I'm going to select everything using Control Shift down arrow. Click on this to be somewhere here, not L. Then I'm going to click on OK. There's a type error again. Oh, we need this to be just here. I'm going to click on OK now. And now I have another analysis done for me. I don't have to actually use all the statistical methods by myself to actually do all of this. Now I can see value of P is actually less than 0.05 for all of them. And my equation is supposed to be more, let's say, granular. Although what I can see now, the R square is very, very less. So we are going to reject it anyway. So for us, whenever we actually try to create a proper analysis, we like to influence on R square and P value both. Whenever we have the R square of more than 60%, that is at least 0.6, and then the P value is for all the variables, or if not all, then some of the variables is less than 0.05, then only we'll be proceeding this. So if we have less than 0.6 here, we're just going to end it right there. We are not even going to look at this at all. For the last example that I told you, we were actually going to that because we needed to, right? Likewise, just like how I selected latitude and longitude, I can say that together they're not able to predict a lot about how the income will look like and whatnot. What you can probably do is actually work around and see how you can work with more number of independent variables in terms of x's. Right now I chose only latitude and longitude. What you have to do as a homework after this lecture is, we have this as textual values. Try to use the same model, this textual value, and see if you're getting an error. For some of the Excel files, if your data analysis toolpack is not very updated, you might get an error. Otherwise, if not, you can also code it. So you can say if this value is being given to you, write 1. If this value is coming, then give 2. Then if this value is here, then give 3. Then it will be, you are actually going to assign a single number to a particular category. And when we're going to run a regression model, then we might be able to have a better understanding of what exactly is happening inside of a data set. So that would be it for how we can actually work on with the regression models. If you have any doubt, you can always contact me. I will love to help you all.